So my talk apparently is called Babbling with Babel or Babel or whatever. It's called Breaking JavaScript into Pieces here, and I'll talk about something in the middle. And the talk is not just about Babel. It's about how would you approach solving a simple task. You have a piece of code. How would you understand it, or how would you transform it? And first of all, like, why do we need it? And there are like multiple reasons why. First of all, maybe you want to build a tool such as Babel. Who here used Babel before, or like knows what Babel is? So Babel is a tool. It started as something called ES 6.5, which allows you to convert a newer version of JavaScript, which is not understood by browsers, to an older version of JavaScript. So basically, the mission of the tool is to look into code, find the pieces which are different from the standard, which is understood by browsers, and then convert them using like some smart algorithms. So you can create tools, or you can also simplify your life. For example, if you work in a team and this happens with me all the time. I write a beautiful code, everything works perfectly, and then I send it for code review, and subject comes back and says, oh, this spacing here, you have double space, you have to fix it. And I don't want to think about this. I want like a robot come and fix this for me. I don't want to ever worry about this. And this is another thing which can be solved if we know how to use how to transform our code. So let's take a look at a simple example. Who here knows what debugger statement does in JavaScript? OK, I'll show a simple example here. We have this code. It's just a function. It's running. If I say like alert hi, it's going to run and it's going to alert. It's going to say hi. And at some point, I may want to debug this function. I want to see, OK, what's inside? What are the variables? What can I do? So I can put a debugger statement here. I just say debugger. And once it runs, it actually pauses my application. And now I'm inside of this function. So I can use console and ask it questions like, OK, what is in the code variable? So I say code. And apparently, there is some string which just says debugger. So this is a simple and nice way to get into your debugging environment. There is one small problem, though. You have to modify your code to do this. And then you may forget. And that happens before. And then you commit this code, somebody else downloads it. It's on their machine. And then they're in a completely different part of the app. And they're editing something there. And then, boom, everything stops. And there is your debugger. And that's not great. So we tried an approach like a simple task. How do we, looking at the code, detect if there is a debugger statement there? So here in my function, we get code coming as a string, as a first and the only argument. And we're going to return true or false, depending on if there is a debugger in my code. So the simplest approach, I'm going to say, if the code match, I'm going to use some regular expression here. If there is just like a word debugger, it's going to return true. And this passes our first test. Yes, there is a code which just says debugger. We found this debugger. That works perfectly. But there is one problem. In the next line, we have a function which says debugger start. And this is not something we want to detect. This is false positive. Here, we want to say, like, wait, this is not a debugger statement. It does not stop my code. I want it to be there. So we have to use the power of regular expressions here to basically say there is a special flag which says this is the border -b of the word. So it will search for only word debugger, and nothing on the left or on the right will be detected. So this helps us to pass the second test. And here, I'm just trying to use regular expressions to see if it works or not. Like, maybe it's a good solution. Maybe we don't need all those like Babel, whatever fancy stuff. Maybe we can just come, like, how hard is it to detect a debugger in the code, right? And I keep going through this, and then I find a different issue. OK, so what if there is a comment and it says debugger, right? So now I have to take the code. I'm going to replace. I'm going to do a regular expression, and I'm going to say like everything which is a comment. I'm going to like literally strip all line, and I don't care about this. And boom, it passes the next test. But now there is a debugger in a string, and it's still possible to do this. So who thinks it's possible to actually solve this with the regular expressions? Like without false positives, you can detect there is a debugger statement in the code and not in like some comments or whatever, or a combination of those. Anybody is brave? No, okay. Who thinks it's impossible? Okay, so just like nobody raised their hands, okay. Okay. So I don't know the answer, I'll be honest. I spent like whole evening trying to come up with different cases, and eventually I have the load solution button, luckily here. So I click on it, and every single case, like comment in a string and something else, this all works for me and escaping, so it is possible. The question is this code something you would want to support when in next version of JavaScript they add fourth version of a quote or something, and you have to come back and you would be like, oh my god, what is this? And it's going to be crazy. So yes, I think it's possible, but it's not the best solution. So the question is like, is there a better solution? And there is a saying that like you don't want to know how sausage is made. So JavaScript is like the opposite. Oops. You actually do want to look inside and see how it's built and what's inside. And we're going to use a parser. So a parser is a special magical thing. What it does, it takes your code and it produces something called abstract syntax tree. And it might sound scary, okay, a tree, but it's actually not that bad. It's just a JSON which has your code represented as a set of JSON objects. And let's look at the example. So for example, here I have debugger statement. And here is a JSON tree which represents this code. And it kind of, okay, it's 100 lines of code. That's looks like a lot. But if you think that tree is scary, look at this tree. It's trying to attack the president of Ukraine. This is a scary tree for real. But seriously, let's look at this tree. Maybe it's not as bad as it looks like. And there is a lot of information about the location of the code. So okay, our debugger starts at like 0's character and ends with 8's character, and there is like more like this is that line and that column. Okay, that's cool. We understand that. Let's just throw it away. And then we only get like 40 lines of code. And then we focus more. Like you know how in those movies you can like focus and you see things better. And once we do, we really care about this ast.program.body thing. So the rest is like a bunch of meta information. There are like some tokens, whatever. We don't really even going to use it. So what we really care about is this body type, whatever, debugger statement. So it's single object, it has a type of debugger statement, and this is our program represented as abstract syntax tree. And oh, that's it, 3 lines. Now I'm going to add the console log hello world, and it becomes scary again. So don't worry about that. But it's just a bunch of JSON objects. And once you understand the inner structure, they're actually really simple to work with that. And if you don't believe me, there is one tree which most of you are familiar with, but are not afraid. And it is DOM tree. So document body, right? Okay, I'm going to say document body. Just a wild guess, how many properties does it have? Okay, no, somebody throw a guess. 100. 100. Okay, I'll give you. It's a round number. Okay, but it's more than 100. 10,000. Okay, it's less than 10,000. 500. Okay, so the answer is 256 properties. I have a snippet somewhere here. Okay, so it iterates over all document body probes, and you get 256. And you work with them every day, and you don't worry they're like, if you JSONify it, it will be like 200 lines of code. It just works, right? And the same with this tree. If you understand how it works, you should be able to transform it easily. And we're going to go and do some examples here. So now we're going to do exactly the same exercise we did before. We're going to look at a code, and we're going to see if there is a debugger statement there. But now, instead of using regular expressions, we're going to use a tool called Babel. And Babel provides you a set of different tools. And first, we're going to use something called parser. So if you remember that magic picture, parser is the thing which takes your code as a string, and it provides you this JSON AST object. So we're going to go with like babylon.parse, and we just pass the code. And I have a log function here, so you can see what it looks like. And we're even a little bit familiar with this tree, right? This is what we've seen before. We kind of can't even use it now. So we can say dot, is it program? Dot body. OK, and now we get an array of our statements, and one of them is debugger statement. So what we're going to do is we're going to use a JavaScript array method called sum. Who is familiar with JavaScript sum array method? S-O-M-E. OK, a few people. I'll show you a simple example. We have an array of 6 numbers. And then I can make it larger. OK. So I'm going to say sum. And then I'm going to pass a function, and there will be some condition inside. So are some of those numbers greater than 4? Who knows the answer? OK, who said yes? You're getting Angular sticker for participating. Somewhere from this corner. You know? OK. OK, take this. OK. So the answer is yes, or in JavaScript language, it's true, right? Now, are some of those numbers greater than 9? Now everybody wants a sticker. OK, so no, false. None of those numbers are greater than 9. So what we're going to do, we're going to look into this list of statements, and we have one right now, and going to say if some of those, and we're going to say node. Let me look at the tree one more time to remember what it is doing. OK, so it has a type debugger statement. So that's what we're going to check for. All right. That should work. Oh, OK. So the reason it does not work is because we're logging it instead of returning. And now that should work. So this works, right? Great. There is one problem. There is one sneaky use case in the end which does not work. And why is that? Let's see the code. Let's log the code and see why it doesn't work. So it is function, OK, hello debugger, and then we are going to log the abstract syntax tree. So is there no debugger statement in the code? Let's search for it. Yes, it's somewhere here, but it's not on the first level. So in the array, there is an element which has a body, which has like another body. So it's not flat. It's somewhere inside of the function. So we cannot just use sum. We have to go like really deep, and we have to check every single element. And this becomes a pain unless we have special tools to do this. And there is a tool called Babel Traverse, which does exactly what we need. So I'm going to, it's included right here. I'm going to, we already get our AST, so I'm going to pass it to Babel Traverse. It also takes an object. And then an object has one single potential value enter, and is going to take a node. So let's look what's inside. Well, first of all, let's actually use debugger statement, which we're now familiar with, and see what's inside of the thing. I'll make it a little bit smaller. OK, so we get something called node path, and then it actually has a type. And then if it's going to go through our tree, and we'll look at every single node, and every single node it will pass to us. And the only thing left for us is to check, OK, if node type equals debugger statement, then we're going to do something. We cannot return from this function, so we have to create a flag. So we're going to say has debugger. It's going to be false. And then if there is a node with the type of debugger statement, we're going to set it to true, has. And in the end, we're going to return the whole thing. OK, so hopefully this will work. Nope. Hmm? OK, I'm going to load solution, all right? Since we don't have that much time. So it's a little bit different here. So instead of passing enter, we're passing a type of a node. So basically, we can put any node type here, and then it will stop, and we can do some magic there. So here, all we're doing, we're setting a Boolean flag to true. So again, just to reiterate, it goes through every single node, every single like small thing in your code, and it looks, oh, is this a debugger statement? And if yes, we set it to true, and then we can see like everything is green, everything is passing. So okay, does it look scary? It does. OK. Let's see if we can do more examples. So now we know how to find the debugger statement in our code. That's great, but that's not what we want. We don't want a thing to come to me and say, hey, remove this debugger statement. We want it to be smart enough to go and remove the debugger statement. So let's see how hard it is with Babel. Instead of having a flag and removing something, we're going to say, OK, we have this node. It's our debugger statement. We're going to remove it. Is this line scary, Michael?
Yes.
OK.
For different reasons, though.
OK. So this is hopefully going to remove the node. I don't know, it doesn't. OK. So all it does, it goes into your code. It finds debugger statement and removes it. It's only 5 lines of code. I understand it may be scary, but if you do it like for like 5 different use cases, it will become like really easy. Like I'm live coding it, OK? Live coding, it's not that scary. And then, so here we have a similar, I only have 5 minutes, and I want to delay the next speaker, so I'm going to go like really quickly through it. But here we have auto-fixing FIT. So who is not familiar, you can have like 1,000 tests in your application, and each of them is defined using it function if you're using Jasmine or Mocha, which are like standard ways of running tests in JavaScript. And then there is a way, sometimes you just want to focus on one single test. So you go to the test, and instead of it, you're saying FIT. Basically, you're adding one letter, and only this test will be run. And again, it works like with debugger statement. It works really well unless you commit this whole thing in, and then one single test is run across your app for everybody, and then like something gets broken, and like none of the tests were run, and it's your fault. And that happened to me, so that was fun. So it's really easy to do here. It's very similar. Instead of removing, we're just saying node.name equals it, and we're searching for identifiers. There is one extra check. So for example, somebody created a variable called feed here. So we don't want to change this. We only want to change this. So we're checking for one of the other properties. Is this a call expression or not? And I'm skipping this. And there is the last thing I'm going to show. There is a tool called AST Explorer. It's literally astexplorer.net. What it does, it takes your code. I'm going to write debugger here. And it produces that AST tree for you in a nice way. So here, for example, if I have something bigger, I can hover on, I can click on fit, for example, here, and it will match it in the tree. So the tree is pretty long, but I can actually look at this thing in the tree. And it allows you to explore abstract syntax tree and understand better, OK, so which kind of statement or what am I looking for? You just go here, you click on it, and OK. So fit is an identifier. That's pretty simple. Who here is familiar with ESLint? OK. So ESLint is a tool which allows you to basically check your application for like some patterns which you probably don't want to follow. For example, if you forgot like a semicolon, it's going to run before you commit your code, and it's going to say, hey, you forgot your semicolon, put it back. And it has like a lot of elaborate rules, but the great thing is that it allows us to create rules ourselves. And I have a debugger statement here, and I'm going to do something very similar to what we did in the first exercise. I'm going to, here we have an object, and this object is passed to our function which traverses AST. So I'm going to say debugger statement here. And then, so if it finds debugger statement, it just reports like, hey, there is debugger statement, whatever. So this is all code I need to run to pass to ESLint. I have to register the rule after this, but like you can just follow documentation to do that. And it's going to look at this code and it's going to find this debugger statement. And it says, OK, so on line 4, column 5, there is a debugger statement. And then you can say, like, remove it. Right. And also, you can pass additional property here, where you just pass another function, and you just say, OK, you got this node, remove it. And then it automatically removes it for you if you want. And the reason why we want to use ESLint and not just like Babel parser like we did before is because ESLint handles like finding all the files in your project. It handles like turning off and on all the rules, and does a lot of work for you. So if you know how to write those rules, then you can basically feed them to ESLint, even though the format is a little bit different because it uses different parser, and different parsers approach things differently, kind of like different browsers. But still, like most of the principles are very similar. So if some point you encounter like a Java program and you're like, OK, I want to parse this Java program and transform something, it will be like the code you will write will be very, very similar. So we'll use some kind of traversal pattern. You'll pass it something which will look for a node of specific type. And once you find this node, you will do something. And this is pretty much all there is. I added a bunch of links. Presentation is available on codelab.fun/AST. This is the link. So if you see me on video, you can go there. If you don't, take a photo or something. And there is no bonus because we're too late. And thanks, Pierre-Auguste Renard, for those photos. He has this Twitter, which makes me embarrassed because he has more followers than me, like 6 times or something. But yeah, so hopefully, at least some of you are less afraid of modifying the code now and understanding the code. Thanks, everybody.